We build applications with the top priority being make it work as soon as possible. The unknown is cost. Cost used to be limited to performance. The more requests you make of your database, the longer the user will have to wait. On the cloud, cost means real money. Every inefficient database request increments your cloud bill a little bit more and pushes your monthly total even deeper into the unknown. In this webinar, RavenDB CEO Oren Aney unveils your CosmosDB Profiler tool, which will dissect how your application communicates with your database and isolates all the ways you can save time and money in merely refactoring a few data queries. You will discover what is the CosmosDB Profiler Cloud Cost Optimization Tool, how to find out the number of calls to the database your application is making, where to find recommendations to optimize your code for faster and less costly data retrieval. Feel free to ask questions by clicking the Q&A button at the bottom of your screen, and Oren will be happy to answer them throughout the session. Enjoy your presentation, and here's Oren.
Hi everyone. We're here to talk about CosmosDB, and more specifically the CosmosDB Profiler. I've been in the area of database performance for longer than 15, 20 years now. And the sad thing about that is that as important as database performance is, most people neglect that. And the reason they neglect that is not because they are being malicious or forgetful, it's because databases today tend to be pretty fast. And for the most part, unless you hit some really strong edge cases, everything is going to work fast. But when you go to the cloud, you start seeing those inefficiencies, not as a slightly higher CPU utilization on some server that is mostly idle. You're going to start seeing that as actual money that in an invoice that you have to actually pay. And that changed the equation by quite a lot. It used to be the case that, the application is inefficient. Okay, so the server is running out, no worries. But at the scale that we are working today and in the environment that we are working, we are having to face a lot of much more complex decisions. And the problem here is that the moment that we move our system into the cloud, the level of transparency we have into the system is greatly reduced. In order to handle that, we have the profiler. This is a new product and not a new product at the same time. For the past decade or so, Hibernate in Rhinos has been providing profilers for relational databases. And now we have been able to change that to work with CosmosDB as well. So given that you're here and talking this webinar, I think that you're familiar with CosmosDB. It's a globally distributed database. It runs on Azure. It's being pushed very heavily by Microsoft. And the key point to it is that it is extremely scalable. This is correct, it is. And the downside of that is this, how you handle the price. And with CosmosDB, the pricing is based on capacity, however much you have provisioned. And the idea here is that you have this notion of request unit and request unit per second. And based on your usage, you're paying for how much request units you have. And you can see here what is a single request unit translate to in practice. So we have 2 kilobyte write in a second, that's a request unit. And there are other stuff that you're paying for, the amount of storage and the network traffic and a bunch of other stuff like that. But for the most part, also relatively stable things, and they don't change very rapidly, and it's very easy to understand them. The request unit is the most important concern. Why is that? By default, you get 400 request units per second, and you can get as much as you want. I think that the maximum now is 40,000 requests per second. And that's interesting because let's consider a simple scenario. I need to render a page, and that page needs to show a list of items. Well, if I'm showing 10 or 15 items, it's very easy for me to consume in a single page, in a single request to the server, 10, 15 request units. If I have 50 concurrent users hitting the homepage at the same time, I now started to hit the 500 request units per second. And now being throttled. Now I'm starting to get too many requests. Now, you already have in the CosmosDB client, you have automatic retries, and it may switch over to another node and all sorts of stuff like that. But that actually only makes the situation worse. I hit the capacity error, then I wait a bit and retry again. And if I'm under enough node, I'm actually exacerbating the problem, making it much, much worse. Now, the client API actually gives you quite a lot of information about what's going on. You can figure out, okay, how much this request cost me, which depends on what sort of database you used and what is the processing abilities that you wanted and what is the size of the document, a whole bunch of other stuff like that. But this trying to track things like that is a huge chore. And there is another issue that you have to take into account. When you are paying for capacity, you need to take into account what is the peak capacity that you need to handle. And it's very common to have order of magnitude difference between standard operations and the peaks. Let's assume that I have a business application and at 9 a.m. on Monday, everyone logs in and look at their details. And so at 9 a.m., I'm going to have a peak of 500 concurrent users, which doesn't sound like a lot, but when they load the page for the first time, we need to fetch everything. And which means that afterward, they're working on the application, they're only touching 1 or 2 items at a time. But for 9 a.m., I have to have 5,000 arguments per second. This gets expensive. Now, something really interesting about the usage pattern of CosmosDB. CosmosDB tends to be something that is used for big systems. Either you have lots of data or you have really complex systems. And that means that the system is hard to understand. You're not going to be able to see the entire system on a single screen. And there are a lot of moving parts. So if there are a lot of moving parts, how do you know what's going on? Try to imagine that you have a car and you pay per mile. But it's not just you who is driving this car. It's everyone in your team. And some of them may want to say, oh, let's go on the joyride. You know what? I want to get this particular action figure, and it's only available 300 miles away. I'm on the company car, let's go on with that. More to the point, even if you start and do everything perfectly, things change over time. And as you will see, it's actually quite easy to get into bad situations, almost because of almost invisible changes. So let's see how we handle that. One way of handling that is to write a lot of logs and then look at those logs all the time. The amount of time that you're going to spend doing that is horrendous. So this is where the profiler comes in. And let's talk about the project that I'm looking at. CosmosDB is a paid service. There are no real applications open source for that. There are some sample applications, but they tend to be too small and too focused. So what I decided to do, I decided to take this application, the Equinix project, and this is something that is meant to teach you how to handle a non-trivial application. This is an architectural sample. And I like that because I looked at this today. I have no idea how this looks like. And I basically converted some parts of it into CosmosDB. You can actually, if you go to github.com/amd/equinix, you will see the repository with my changes. Please note, I took a hammer to the code base in order to make it work. It's actually ideal, because when we're talking about large applications, it's hard to understand everything that's going on. So let's see what the structure is. This is the structure of the Equinix project. And as you can see, it's not too small. In fact, it's quite complex, and there are a lot of moving pieces going on here. I only touch stuff here and here. And what I had to do, I installed this package. Let's go and look at some code. I installed this package using NuGet. And somewhere around here, I registered the database. Here we go. And I told, let's use the CosmosDB profiling integration on the Cosmos client that I got. That's it. Now let's run the application. This is what it looks like. And this is what it does. It shows me some customers. Here's what it looks like on the profile. So the first thing to note is that there is quite a lot of information that we display to you. Here are all of the queries that were generated when I access this page. You can see the query itself. We can drill down. Might be better to look here. Here are the results of this query. And I can see how this correlates directly to the data I'm seeing here. Other things that are important is that you can see here the request units that each one of them took. And here is the total request units that we've used so far. You can see that assuming that we have 100 requests a second, this thing would cost us 10 cents, 17 cents. But if I'm going to click this a few times, this is going to start adding up. In order to handle this, I would probably need quite a lot of values. That gets to be expensive. The other thing that I want to focus on is the kind of visibility into the system that we get. So we can see here the requests that were generated by this. Let's look at edit. And we read a document by ID, which is great. Now let's modify it. And we did some read. I don't know why this is. We uploaded the document, and then we created customer updated event. Notice that what I'm doing here, I'm making changes in the application and looking what it sent to the backend. And again, looking at this code base, it's anything but trivial. There's quite a lot of code here. It's non-trivial architecture that you have to take into account. And that's something that we have to deal with. But I don't know how to handle that. That's too much stuff going on at once. So I can look at, here is my code, here's my UI, and here's what's going on behind the scenes. Now, let's go here. And this is strange. I don't understand this. First of all, I can see that this is non-trivial expense. So if I have 10 requests per second for 20 requests per second updating a customer, that's going to be really, really expensive. So let's try to understand why. And I can see here that I'm doing a select, upsert, and insert. Let's figure out what this is happening. And I can ask the profiler, tell me what happened. Why do you have this? There's a whole bunch of stuff that I don't care, but then I have a get by email. And this is interesting. Customer command handler. The profiler takes me to the specific kind of code that generated this query. And now I can see, oh, okay, you're checking if the customer exists or not. Makes sense? And then you do an update. And then you're raising the customer update event, which is this thing. Can't tell because of this. At some point, there is a raise event, and it goes to the Cosmos event store, and it reaches the save method magically. However, I don't know. The whole idea is that I don't need to understand that. What I do need to understand is how everything come together. Now, other things that we have to look at are the details of what's going on. So you can see, okay, here this is how much it takes me to run this. By the way, I don't know if you are aware of that, but I'm actually running this against a local instance of Cosmos, so the emulator instance. You can run it against the emulator or the real thing, it doesn't matter to the profiler, and things work, and you get the, okay, here's how much this request cost me in capacity. So it's not necessarily, it didn't cost me, 6 cents, but it did cost me the, if I have enough of them, you're going to start seeing the actual cost pile up very quickly. And the structure is it. Now, we're going to start seeing a lot more interesting things when we start looking at the query metrics. And again, if you have a problem, it's very easy to dig in and understand what's going on. This is just part of, look, oh, you can see that I'm getting here low amount of data. If I'm getting here and I'm asking, and I can see that, okay, I have quite a few records here. So still pretty minimal, but that's the total size of the documents. Other things that are interesting. I'm running my query. I'm running, everyone is happy. There is an issue here. And the issue is that I have these alerts. And these alerts basically tell me, hey, stop what you're doing. There is something wrong in your code. So there are green and orange ones. Let's look at orange. And I can see that I have a select n+1 error here. A select n+1, and it's very easy to see. Here we have, okay, give me everything from the customer's collection. And then let's start doing queries based on the customer ID. And I'm starting effectively, why am I making so many different calls? I could probably make it in one shot. So let's see where it's coming from. And we can see that it's coming from the order count method. And by the way, I don't know if you noticed, but look here. This is being generated from the HTML, it's not the HTML, the CSHTML. So as part of rendering the view, we're issuing a query to the database. And for me, this is absolutely insane thing to do. And why is that? Let me show why is that. Because what happened if I iterated over this twice? That means that you're getting control over something very critical to your application. The actual generation of database queries to the system, in which case this is actually tied to your credit card to the view. And who is going to work on the view? Probably the people who has least interest in database interaction. And it pops right here very, very clear. But let's go here and see where we're at. And now I can see something interesting. Okay, I'm doing this query. And after I do this query, I'm asking get order count for each one of them. So obviously this is a select n+1. For each customer that I'm getting, issue a separate query. it would actually be far more efficient for me to do it by using an in statement. This way, in this case, I would have just 2 such queries instead of 7. So that's one thing that the profiler tells me. Another thing that it tells me, which is interesting, is that further queries with the partition key value in the filter class for low latency. And that's really a mouthful. So let's talk about this. One of the primary features of CosmosDB is that it is partition. That means that for every piece of data in CosmosDB, we have a field that serves as the partition key, which is how you distribute the data among different locations. But what does it mean? In this case, let's go and look at the data. I'm querying over orders. Here's orders. I can see that the partition key that is the customer ID. So all orders are for the same partition, for the same customer going to live in the same partition. Given this piece of information, I can go here and say, you know what? Now, this seems like a very minor thing to do. Let's run it and see what's going on. Then understand why it matters. So right now, the course is 3.16 RU, which is not too bad. We're running the system. Now, you can see that I have no alert here, but only here for the selected +1. So what's the difference? Why is it important? You can see that the request unit that I consume is the same for both cases, but it's actually very different. If I'm looking here, when I'm saying, oh, you have a problem, what is CosmosDB have to do? It has to go into the orders container and issue this query over all of the partitions in the database. Let's say that I have 20 partitions. If I have 20 partitions, then we're going to have to issue that query on all 20 partitions. So instead of this costing me 3.16 RUs, it's actually going to cost me 63. And while I'm running this kind of query in development, when I'm starting, I have just one partition that I'm running on the emulator. I'm not going to see any such things. When I'm going to production and my data start to shift because of the amount of data that I see, this kind of small thing is going to have a huge impact on the system. So let's see some other things that the profiler can tell us. There's actually a huge number of such features. We have looked into best practices and how things are working in order to understand where people are failing. So let's talk about something relatively minor. I have a business rule that says that you cannot have okay. Customer email has already been taken. Makes sense. Let's see how it works. Here it is. I'm running this. I'm finding that, oh, I have a result for this. We're good. Now, let's see something interesting. And this works. And this is really interesting. How could this work? And if we go to the list, it will be very obvious. This and this are not equal because the query is running using case-sensitive batch. Let's go and fix that. This happens here. So I'm going to change this code. This code. Now, to understand what's going on, I'm saying, give me the first item that matches the law of the email, and I'm calling here to learn. So basically, I'm doing to learn on the query. And now I'm going to be able to do case-insensitive match. So let's try it now. Perfect. And I could go here and see that it worked. Okay. But I see that there is an issue here. In this case, the first issue is server query with partition key, blah, blah, blah. This is interesting. I might want to decide how do I want to model the customer. Maybe if I'm always looking up by email, I need to do it this way. But for now, let's ignore it. The critical thing from our perspective is this. Upper or function user prevent utilizing an index. Now, let's go here. This costs 2.89 RUs. This costs, basically it costs the same. So whatever I use to lower or not have very little impact on the RUs right now. And this is something that is really critical to understand because it's easy to get the issue, to get to the issue when you are already suffering from it. The old joke about a guy that goes to the doctor and says, it hurts when I do this, so don't do that. But you don't know at this point that this is bad. You just want to close the issue about, oh, this is something that you just want to complete. So a lot of those things are effectively hidden for you. It's just something that you're not necessarily going to see. And the profile is going to expose that and make it very obvious what's going on. Now, some of the things that are important are what we're going to find. So against the CosmosDB instance, we're going to find bad queries, stuff that is inefficient, like with the lower, queries that don't utilize the index properly, things that are going to cause you to scan through a lot of data, things that cause you to make cross-partition calls, those sort of things. But that's just one side of it. The profiler is capable of giving you information about what's going on inside your application that may impact the efficiency of your system. For example, if you're running an overloaded thread pool, you're running the capacity of your client machine. All of the work inside of the CosmosDB client is done in an async fashion. And what that means is that if you have an overloaded thread pool, you're going to start seeing much higher latencies that are effectively going to be invisible to you. Because from the point of view of the CosmosDB monitoring tools, the queries are fast. It's just that from the client side, you're unable to schedule them fast enough to matter. And that can be a horrendously complex problem to try to solve. Other example might be, oh, let's look at update. I'm updating an item. But you know what the problem here? if I did this, just this change, we're going to be far better. Why? Because we don't ask the client, and again, this is the client that is sending this information to figure out what the partition key is. And if we need to do that, that's much more expensive because we have to do serialization, deserialization on the client side. And again, something that is completely transparent to the server, but has huge impact on your system. Finally, and this is a really interesting story, and I recommend going and looking at that. It's really strongly recommended that you reduce a singleton CosmosDB client. You can see how I've done that here. When I'm registering that as a singleton. What happens if this is not a singleton? Then every request that you're making, you're going to start seeing, oh, I see some, every request you're making, you're going to see a pulling of data, some metadata from Cosmos, which cost you are used. In the case that I have here, just making the client singleton reduce their cost by 80%. So they paid $1,000 one month, then they paid $200 in the next month. That's insane. And the other side of things is that if beyond just the bill that you're paying for no reason, you're going to have to face with this, with users that are being blocked because your system isn't efficient, hitting the limits of your capacity. So at that point, you have to massively over-provision. The profiler is going to help you figure out what's going on there. I already showed an example here. This is a very minor bug, but it's very easy to get lost in. One of the primary benefits, I think, of what the profiler gives you is it allows you to bridge between these two views. As a developer, I'm looking at this, and I'm looking at this single function, single query at a time. As the architect, I'm looking at this. Here is the overall picture. But what I'm missing is not just here is a single query, here is the overall picture. I'm missing all of the interactions, all of the things that are being exposed to. And it's amazing what happens when you start looking at that, you start to understand that. Oh, here I can see that I have quite a lot of items. By the way, notice that here I have, I'm reading the event containers. So I can actually reduce the amount of work that I'm doing here as well. I can get some data here, but the system, whatever. But probably most importantly, from my perspective, I have this. I can look at the system. Okay, I see that upsells here was quite expensive. And here's some other ones. In this case, I don't have really expensive queries. As you can imagine, I have about 10 documents in the database. Not too complex to get this efficient display. But it means that I have very easy ways of seeing latency, seeing the actual cost that I have without thinking about that. I can even start looking at the data from this perspective and saying, okay, here is, let's try to find the edit controller. What does it cost me? The create, what does it cost me? All of those, and give me really interesting information. I can look at the alerts and see where do I need to fix and what do I need to fix. Oh, this is something important. Let's go and fix that. Those sort of things. And finally, you can get some overall usage. Here is what I have. This is what I need to work with, stuff like that. Something really interesting, and again, you can look at stack trace analysis. The level of insight you get into what's going on is quite important. And I keep repeating that, and It matters. It matters because if you're looking into reducing your cloud bill, if you're looking into improving your latency, improving the speed in which users can interact with you, this matters. And this can be grudge work, where you have to troll through logs and try to do everything manually, or it can be something that is blindly obvious that the profile is going to put a big red dot on here the things that you need to pay attention to. Really important, you can plug this into your continuous integration system. So the typical scenario is that you're going to run this in your system. And again, the actual edit to your system is, okay, edit to your NuGet and call this and then you're done. And now you're able to start tracing whatever is going on in the system. And you get the final tally of, okay, see how much this run is going to cost me. And then, after you have done the fourth window, the fourth stage of running this and fixing all of the obvious things, you can plug it into your CI. And then you can break the build if someone does something that's going to cost you. And you don't have to do that by, oh, let's spend 2 weeks performance optimization. This is something that's going to be ongoing. And if you have someone who is going to fix the bug by making this kind of code, not this kind of code, this kind of code, which looks reasonable. That's the problem. If you look at the PR like this, you're very likely to say, oh, okay, makes sense. You don't notice that, oh, you actually can't use an index here. So we're doing a scan. This is now really, really expensive. Now is the time for questions. I ran a poll earlier, and we got some really interesting details from it. There are quite a few people who are already running CosmosDB or in the process of developing to it. But most of you are either hoping for the best or manually tracking the changes. Dylan is asking, looks great, when is the release and what is the pricing model? The release is this month. You can already go, you can already go to the website and download that, try it out. In terms of the pricing model, this is priced on a per developer basis. The assumption right now is that you're going to be running that on your system. There is another piece of this that is going to be running on your production system to give you additional information, but for now, the pricing model is on a per developer basis. Sunil is asking, is this profile neutral to NoSQL Dialect, Cassandra, or MongoDB that run on Azure? No. This is actually running as on CosmosDB only and only using the simple protocol right now. If you're using the MongoDB or the Gremlin protocol, that's something separate. From our experience, the distribution is very heavily weighted toward the SQL models. This is what we're doing there. Jeff is asking what SDK version are supported, and 2 and 3 are supported. We recommend that you will use the tree model because it allows us to give you more information from the system. For example, I think that this is coming from the tree version, and we can provide all of that in the 2 edition, but it is supported. Daniel is asking, CI counted as a server? No, the CI, if I remember correctly, is not counted as a server. The developer who is setting up, yes, but the CI, no. Okay. Any additional questions that you have? So I was about to say that most of you are about the poll. Most of you are either manually tracking the billing charges, but for the vast majority, so sorry, 22% are manually tracking, but wow, almost 80% are either hoping for the best or letting someone else pay the bill. And that's really interesting because this has been my observation that, oh, we're running the cloud and there is this huge discrepancy between the users who are the people who are developing the systems and the people who are paying for it. And usually, and one of the reasons that we build this is that by the time that you start thinking about the performance, the application is now large enough that it becomes really hard to manage. So you can't do things on your own. You want to have some additional help. And don't think there are any more questions. So guys, thank you very much. I had a lot of fun doing this webinar. If you have any additional questions, please feel free to ping us at support@hybridadvantage.com. I'll be very happy to answer your questions. Thank you.